So the other day we were discussing problems based on basics of rotational motion, moment of force, and angular momentum, right? So we saw a few problems based on them. Now we will see the next concept, that is conservation of angular momentum. Okay. So today we'll start with that, then we'll go to moment of inertia. So write down the heading, conservation of angular momentum. Okay. So if I ask you to speak about conservation of conservation of linear momentum, what will you say? So what is the statement for conservation of linear momentum? When is it said to be conserved?
When the external force acting on the system is zero.
Yes. When external force acting on the system is zero, that is, if dP by dt according to Newton's second law is zero, then we can conclude that P is a constant. In a similar way, you guys tell me, when do we say that angular momentum is conserved?
When external torque is zero.
Very good. So when the external torque is zero, we can say that the rate of angular momentum is also zero. The rate of change of angular momentum is zero. From this, we can conclude that angular momentum is conserved. Right? So when I say angular momentum is conserved, the initial angular momentum of the system is equal to the final angular momentum of the system. This is a known fact. But what is the formula for angular momentum? We know that L is equal to mvr sine theta. If I write it in vector form, it is mvr sine theta n cap or r vector cross p vector. Right? If I write it in scalar quantity, it is mvr sine theta. By manipulating it, we know we get a formula L is equal to I omega, where I is the moment of inertia and omega is the angular velocity, right? So when that is the case, can I write I1 omega 1 is equal to I2 omega 2? So this will be the mathematical condition for the case where you need to say that the angular momentum is conserved. Got it, guys?
Yes, sir.
Yes, sir.
So it's the simplest explanation. Okay. Okay. So make a note of this. Based on this, we will do some problems from the previous DPP which I shared with you. That is DPP 9, rotation mechanics. So I told you first few problems we didn't do, right? We will do. So read the first problem. You keep reading the question from your WhatsApp.
One minute, could you scroll up?
Yeah. Just a minute. Done?
Yes. Thank you.
So here we have a thin circular ring. Okay. The circular ring is thin, means its thickness is ignored, of mass m and radius small r, is rotating about its axis with a constant angular velocity omega. So you have a thin ring like this, which is revolving about its axis with an angular velocity omega. Four objects, each of mass m, are kept gently to the opposite ends of two perpendicular diameters of the ring. The angular velocity of the ring will be. So there are four objects each of mass small m, which are placed on diametrically opposite ends, and those two diameters on which they are placed are mutually perpendicular to each other. This is one diameter, this is another diameter. Right, this diameter is existing, whereas this is the axis through center of mass and perpendicular to the plane of the ring. Okay. Now they are asking what is the angular velocity of the ring. How do we proceed with this? Okay. So initially what was happening? Let's analyze the physics behind it. Initially, the ring was revolving with angular velocity omega and moment of inertia of how much value? So what is the moment of inertia of a ring about its axis? It is mr square. Okay, have this in your mind. So moment of inertia of a ring about an axis passing through the center of mass and perpendicular to the plane is mr square. So finally, what is happening? Finally, the ring is still revolving along with 4 extra masses of how much value? Small m. And moment of inertia of how much value? So what is the new moment of inertia? I dash will be equal to the moment of inertia which is already existing for the ring, that is capital mr square, plus how many masses are added? 4 masses, right? So 4 times m into each mass is at how much distance from the axis of rotation? The same, smaller. So 4m into r square. Why did I write 4m r square? Because each mass will have a moment of inertia of mr square, and we know it's a scalar quantity. So it will get added times, let's say the new velocity is omega dash. Okay. Oh, wait. This is the moment of inertia. So let the new angular velocity be omega dash. So from this we can conclude that I1 omega 1 is equal to I2 omega 2. What is I1? I1 is capital mr square into omega 1 is omega is equal to I2 is capital mr square plus 4m small r square into omega dash. So r square gets cancelled. Omega dash will be equal to capital M omega divided by capital M plus 4 times small m. Is that what they are asking? The angular velocity of the ring will be. So m omega by capital M plus 4m. I think, yeah, it's the first option. Copy it first. Done. I'm going to the next one. So second one, the angular momentum of a system of particles is conserved when no external force acts upon it, when no external torque acts upon it, when no external impulse acts upon the system, when the axis of rotation remains the same. Answer is when no external torque acts upon the system. Third, I think it's a problem. So let's see. Two rigid bodies A and B rotate with kinetic energies E and EB respectively. The moment of inertia of A and B about the axis of rotation are IA and IB respectively. If IA is equal to IB by 4 and EA is equal to 100 times EB, the ratio of angular momentum of A to the angular momentum of B is. So EA is how much, guys? Half IA omega A square. So EB is what? Half into IB into omega B square. That's what the information is. The moment of inertia of A and B about the axis of IA and B respectively. IA is equal to IB by 4. EA is equal to 100 times EB. So what we will do is, we will write EA in terms of EB. So 100 times EA is equal to half into IA is IB by 4. IB by 4 into omega A square. And EB is still this value only. The ratio of angular momentum LA of A to the angular momentum of B. Okay. Angular momentum of A to the angular momentum of B is half IA omega, IA into omega A divided by IB into omega B. So IA is how much, guys? IA is IB by 4 by IB. We need to know what is the value of omega A is to omega B. Right, IB will get cancelled. So omega A divided by 4 times omega B is what is angular momentum. But the question here is, we need to eliminate omega and omega B. How do we eliminate it? We know that EA divided by EB is equal to 100, which implies, what is the value of EA? Half into So what is omega A by omega B, guys? It is 20. So if it is 20, 20 by 4 will give you 5. Did you understand what I did?
Yes, sir.
Make a note of it. Okay. So if we want to find the shortcut, how to solve this problem in 2 steps. So what is the relation between linear momentum and kinetic energy? This we have seen in de Broglie's wavelength also. So relation between linear momentum and kinetic energy. Kinetic energy is written as P square divided by
2m.
It is 2 times m, which implies P is equal to root of 2m into k. So what will be the equivalent of linear momentum here? Angular momentum is equal to root of 2 into the equivalent of mass here is
Moment of inertia.
Moment of inertia.
into kinetic energy. Okay, root of 2 into I into k will be the formula. You can just use them and directly find the answer. Okay. Next, a uniformly heavy disk is rotating with a constant angular velocity. I don't think. Let's see. A uniform heavy disk is rotating at a constant angular velocity omega about a vertical axis through the center and perpendicular to the plane of the disk. Let L be the angular momentum. A lump of plasticine is dropped vertically on the disk and sticks to it. Which of the following will be constant? So which will be constant? There is actually a theory question. This problem is similar to the first one, except the fact that there it was ring, here it is disk. Okay. So when you drop any object onto it, so disk is revolving like this. On this, there is an object that is dropped and the object gets stuck to it. So when the object is getting stuck to the originally existing material, what will happen to the moment of inertia of the system? Will it increase or decrease? Or to put it in very simple
Increase.
terms, it will increase because there is already existing moment of inertia mr square by 2 plus this mass will also add to it, m into small r square. We don't know what that r is because the information is not given. So when the moment of inertia is changing, will the angular momentum going when the moment of inertia is changing, will the angular velocity be the same or constant?
Vary.
That will also vary because here, when this object falls on this disk, what is going to happen is the object is going to start revolving. For any object to revolve, there is a torque that is necessary. But if you look at the small object is revolving due to the internal torque that is existing, not due to the external torque. We are not applying any force. Since the external torque acting on the system is still zero, we can say that the angular momentum alone is quantized. Not quantized, sorry, conserved. We can say that the angular momentum is conserved. Okay. Next. Two disks of moment of inertia I1 and I2 and angular speeds omega 1 and omega 2 rotating along the collinear axis, passing through the center of mass and perpendicular to the plane. If the two are made to rotate combinedly along the same axis, the kinetic energy of the system will be. Let's calculate. So how to do, guys? So two disks of moment of inertia are individually revolving with angular velocity omega 1 and omega 2. So what will be the initial angular momentum? Now tell me one thing, guys. When these two disks are put together, right? The system is still revolving. Is there any external torque acting on the system?
No, sir.
No, right? So here also the angular momentum is conserved. So initial angular momentum of the system will be I1 omega 1. That is the angular momentum of the first object plus the angular momentum of the second object. What will be the final angular momentum? That will be, it is very much similar to the perfectly inelastic collision, right? So it will be I1 plus I2, that is both the moment of inertia will get added and they will have a common velocity omega, right? So since they're asking the final kinetic energy of the system, kinetic energy final is equal to half into I1 plus I2 into omega square. So it is half into I1 plus I2 into what is the value of omega? It is I1 omega 1 plus I2 omega 2, the whole divided by I1 plus I2, the whole square. So it will be half into I1 omega 1 plus I2 omega 2, the whole square divided by I1 plus. Which option is this? Third. Clear, guys?
Yes, sir.
You can expect questions from angular momentum, the conservation concept. So particle performs uniform circular motion with an angular momentum L. If the frequency of the particle's motion is doubled and its kinetic energy is halved, the angular momentum becomes what? You guys try and tell me. So what is the answer? How to approach? How to approach, guys? So what is the
Omega,
information?
omega
Yeah,
is
tell me.
equal to 2 pi f, and then you get half.
Yeah, omega is 2 pi. Omega is equal to 2 pi f. Okay.
Omega dash will be equal to pi f after it's half.
Frequency is doubled.
Frequency is doubled. Okay. Got
4 pi f. That's right. So what is the initial kinetic energy? Half I omega square. Final kinetic energy?
I4 omega square. 2 omega.
So it is half I into 4 pi square f square. Final kinetic energy will be half I into 16 pi square f square. They told kinetic energy is half. So Ke dash is equal to what? Okay. So now what we need to do is, this is not going to work because we need to relate the kinetic energy and the angular momentum. I gave you a formula. What is it? See, kinetic energy is half I omega square. Can I write it as half into I omega into omega? So I omega is L. So half into L omega. Right. So if the initial kinetic energy Ke is half into angular momentum L into initial angular velocity is 2 pi f. So what will be the final one, guys? It will be half into L dash into, can I write it as 4 pi f? And the final kinetic energy is actually what? Ke divided by 2. Did you guys understand what I did? Because the kinetic energy is half. So now divide both. When you divide both, you will get, so 2 and 2 will get cancelled here first of all. So Ke divided by Ke is equal to half into L into 2 pi f divided by L dash into 4 pi into f. This and this will get cancelled, which implies this and this will get cancelled. L dash will be equal to L pi. Okay. So L dash will be equal to L divided by 4. This is the answer. So let's do one more problem and then we'll move on to moment of inertia concept. I hope the problems are easy only, right?
Yes, sir.
Yes.
So let's do them. So round disk of moment of inertia I2 about its axis perpendicular to the plane and passing through a center is placed over another disk of moment of inertia I1 rotating with an angular velocity omega about the same axis. The final angular velocity of the combination. You need not even do this. There is a part of some other question which we already did. So the disks were initially revolving separately. No. Only the disk with moment of inertia I2 was revolving, and there is another disk which was initially at rest. The second disk is dropped onto the first disk.
So is it option C?
Wait, that's what I'm checking. A round disk of moment of inertia I2 about its axis perpendicular path is placed. Oh, that is placed over another disk. Okay. Then option C is right. That's it. So these are all some problems which are based on conservation of angular momentum. Now the next concept that we are going to discuss is moment of inertia and radius of gyration. That is, we will see the values of moment of inertia of simple geometrical shapes. Whatever was there in your CBSE is only what we are going to see. Okay. So I've already told you what is moment of inertia. What is it?
Resistance to motion.
So resistance offered to the torque applied on the object, right? And we also know I is equal to, what is the formula? Let's look at it mathematically. So what is the formula for moment of inertia? So it is represented by the symbol I. So I is equal to m into. So moment of inertia formula is generally given for particles. It is given as m into distance square. That is mass of the object into distance from the axis of rotation to the point where it is placed. So m into d square, right? For extended objects, what is going to be the value? I will be equal to integral of dm into r square, right? So just like how we solve problems based on any other concept in physics, we need to do the same thing. Define its density, then we have to find its mass and all those things, right? So integral of dm into r square is going to give us the moment of inertia for extended objects with proper limits. So there are certain moment of inertia which you're supposed to know. Just give me a minute. So write down the values of moment of inertia. So moment of inertia of rigid objects. So first, when you talk about a uniform rod about a perpendicular bisector, that is, you have a rod which is revolving about its center and a perpendicular to the length. So what is the moment of inertia of it? If the mass of the object is m and the length of the rod is L, what is going to be the moment of inertia of it? It is ml square. Anybody remembers this? It is ml square divided by 12. So I will show you the derivation for this part alone so that you can understand how to apply it in other problems also. So let's see the derivation. So what is the type of density we can define here?
Linear density.
So linear density is mass by length. So I told you moment of inertia is integral of dm into r square, right? Means we need to consider a particle mass of thickness dx, which is at a distance x from the axis of rotation, right? So what will be the value of dm? Lambda into
dx.
Integral of
dx.
dx.
No, lambda into dx, that's it, no integral. Still, I have not applied any concept. So dm is equal to lambda into dx. So what is the moment of inertia of the smaller mass? See, why we are doing dm is because there is a formula only for particle mass. So by taking the dm itself is treated like a particle mass. So di will be how much? The mass of the particle into its distance square, x square. So di is equal to dm into x square, which implies di is equal to lambda into dx into x square. So what will be the value of I? I will be the integral of this. Now you understood why it is integral of dm into r square. Instead of doing summation, we are actually doing integration. So lambda taken out, x square into dx, right? So lambda into, what is the limit we need to take as? The value of x is going to vary from where to where. If I take the center as origin, then the left hand side will be at a distance of minus L by 2 and the right hand side will be the coordinates L by 2. So can I write minus L by 2 to L by 2? So minus L by 2 to L by 2 is going to cover the whole rod. So lambda into integral of x square dx is going to be x cube divided by 3 from minus L by 2 to L by 2. So lambda is m by L. Actually, that 3 will also come out into L cube divided by 8 plus L cube divided by 8. So this will be m by 3L into 2L cube divided by 8. It will get cancelled. So L will cancel this 2 times. Answer will be ml square divided by 4. Got it?
Yes, sir.
So in a similar way, the moment of inertia is derived for all other particles as well. Next. So moment of inertia of a ring. About what? About its axis. So whenever you are defining moment of inertia, the axis of rotation is important. About its axis, perpendicular to plane of ring and passing through its center. So what is the answer? This we have already seen. It is
mr square.
mr square. Similarly, for a disk, perpendicular to plane and passing through center, it will be mr square divided by 2. Okay. The disk is also sometimes in the questions it is given as circular plate. So this also should be understood. Next. Fourth, cylinder about its axis. So when I say cylinder, I'm talking about a solid cylinder. When you're talking about a solid cylinder, it is mr square divided by 2 when it is passing through its axis. Next, when you talk about a solid sphere about any diameter, solid sphere about any diameter, what is the value? It is 2 divided by 5 mr square. Sometimes they will talk about a hollow sphere also. So hollow sphere also about diameter. It is 2 by 3 mr square. Okay. So these are all the values that we are supposed to know as of now to solve problems. Next is, so after all these things, we need to understand what is radius of gyration. I'm sure you would have heard this word also. So what do you mean by radius of gyration, guys? It is a distance from where?
Distance between center of mass and axis.
No. It is distance from axis of rotation. It is the distance from axis of rotation where the moment of inertia of the object will be the same as its original value. I'm giving you a simple definition of it. So the meaning of it is, see, if I take a rod of mass capital M and length L, what is the moment of inertia about its perpendicular bisector? That is ml square divided by 12. Okay. But from the same axis of rotation, if I place a particle mass of same value m, then I should place it at a distance k, which is called as the radius of gyration, in such a way that what will be the moment of inertia of this particle mass according to the formula mk square. This mk square should be equal to ml square by 12. Means what I'm trying to say is I need to replace an extended mass with a point mass of the same value capital M and place it at a certain distance from the same axis of rotation such that the moment of inertia of that particle mass is exactly equal to the moment of inertia of the extended mass. So what will be the value of K? L by root 12 or L by 2 root 3. So this is called as the radius of gyration of whom? Of a uniform rod which is rotating about its perpendicular bisector. Similarly, if I ask you what is the radius of gyration of a solid sphere, what will you say? Mk square should be equal to, so Mk square
2
is
by
fixed to
5
what?
mr.
That's it. 2 by 5 mr square. M and M will get cancelled. K will be root of 2 by 5 times r. So radius of gyration is fixed. The formula of moment of inertia in terms of radius of gyration is simple. Mass of the whole object into k square. That should be equal to whatever is the moment of inertia that you know for that particular object. 2 by 5 mr square. Similarly, for a hollow sphere, it will be root of 2 by 3 into r. Right? So these are all the concepts that you're supposed to know. With this knowledge, we will start solving the problems. If anything is needed, at that point, I'll explain. So 5 particles of mass 2 kilogram are attached to the rim of a circular disc of radius 0.1 meter and negligible mass. Moment of inertia of the system about an axis passing through the center of the disc and perpendicular to its plane is. So there is a disc. So to the end of the disc, there are 5 particles, 1, 2, 3, 4, 5. Okay. And the disc is still revolving about an axis passing through the center and perpendicular to its plane. So what is going to be the moment of inertia of the system? Moment of inertia of the system is equal to moment of inertia of disk plus the moment of inertia of particles. But here, what is the moment of inertia of disk?
ml square by mr
But you
square
need to
by
be
2.
but you need to be careful with something. Read the question carefully. Circular disk of radius 0.1 and negligible mass. So disk does not have any moment of inertia, it is zero. So the moment of inertia of the system is only due to the particles. That is going to be what? M into R square, where M is how much? 2 into R square is 0.1 square. But this is due to one particle. Since 5 particles are there, multiply it with 5. So you will get 10 into 10 power minus 2. That is 10 power minus 1 kilogram meter square. Answer will be 0.1 kilogram. Am I clear, guys? Try the next one. Two disks of the same material. So wherever you see a question stating same material throughout physics, then their density is the same. Okay. So two disks of same material and thickness have radii 0.2 meter and 0.6 meter. Their moment of inertia is about, their moments of inertia about their axis will be in the ratio of what? Tell me one thing, guys. A disk with thickness is equal to what? If you have a disk with some thickness, then
Cylinders.
it's a cylinder actually, right? So when you're doing the second question, we need to be careful. Second question is, so two disks of the same material, density is constant, and thickness 0.2 and 0.6. Then their moment of inertia. So since the, see, if it was only disk, then the type of density we would have defined as areal density. Since it's a disk with thickness, we are defining its volume density. So what is the moment of inertia of the first disk? It is mr square by 2. Or in general, moment of inertia is mr square by 2. So I1 by I2 is equal to, in the place of m, can I write it as a density of substance into its volume? They didn't give anything about the radius. So rho into, okay, let's take the radius as pi r square. Let's take the radius as r. So rho into pi r square into its thickness, let's take it as h. I'll call it as h dash into r square divided by 2 divided by rho into pi r square h double dash into r square. So here one correction we need to do is R1 and R2 because we don't know about their radii. So rho will
Radius
get
is
cancelled.
given, sir.
Where have they given?
0.2.
Oh, they have. Okay, okay. I read the question wrong. I thought the thickness is different. They have the same thickness, sir. Okay. So thickness is same. H is same. So pi and pi will also get cancelled. H and H will get cancelled. So I1 by I2 will be equal to what? R1 power 4 divided by R2 power 4. So R1 power 4 is 0.2 divided by 0.6 the whole power 4, that is 1 by 3 the whole power 4. 1 by 3 whole power 4 is 1 by 81. Right? Third. So there is a cylinder of mass 500 grams and radius 10 centimeter, has moment of inertia about its natural axis. So what is the moment of inertia about its natural axis? It is mr square divided by 2. By substituting the formula, you will get the answer. So this part I'm not doing. So let's do the fourth one. So there is a constant torque of 31.4 Newton meter is exerted on a pivoted wheel. If angular acceleration of the wheel is 4 pi radians per second square, then the moment of inertia of the wheel is how much? So what are all the data that is given? Torque is equal to 31.4 Newton meter. Angular acceleration is 4 pi radians per second square. Moment of inertia. So we know the torque is equal to I alpha, that's it, right? So 31.4 divided by 4 pi. Calculated, that will give you the answer. So that part I'm leaving it to you. Now we'll do the fifth one. From a uniform wire, two circular loops are made. And in the first one, the name of the loop, the circular loop is P. It is of radius small r and Q is of radius nr. The moment of inertia of the loop Q about an axis passing through its center and perpendicular to the plane is 8 times that of P about similar axis than the value of n. So diameter of the wire is very much smaller than r or nr. Okay. So it is P of. So how to proceed this? You guys tell me how to proceed. So there is a uniform wire taken and it is converted in the form of a circular loop. So for us to, so let's think logically, okay. Since they're saying about moment of inertia is md square. So what do I need? So since they have told circular loop, for a circular loop, I know the moment of inertia is m into r square. So what are all the data that we need to calculate the moment of inertia of circular disk? We need to know its mass and we need to know its radius, right? So here, is there any information that is given related to mass?
No, sir.
Yes or no? Is it given?
No, sir.
then how do we find it? So it's not possible for us to find it directly, but we can use a proportionality concept in the sense. See, for me to construct a circular loop of radius r, let me say, I need a wire of this much part. Okay. For NR part, let's say I need a wire of this much length. Are you guys able to understand? So here one important point is from a uniform wire means if the mass of this wire is m, then what will be the mass of this part of the wire? Right? It will be n times m because this is what is going to get converted into a circular loop of radius nr. So if I have this idea, remaining things is easy for me. They're asking what are they asking? The value of n, right? So I1, the moment of inertia of loop Q, that is I2 is equal to 8 times I1. So I2, what should I write, guys? Nm into, what is the radius of this part? Is equal to 8 times I1 is mr square. So n cube mr square is equal to 8 times mr square. So n cube is 8 means n is 2. Am I clear? Did you understand how to take the data from the question? Yes or no, guys?
Yes, sir.
Good. So make a note of this.
Sir,
Yeah, tell me.
how did the mass become Nm?
See, that's what I'm trying to say. They're saying uniform wire.
Yes, sir.
So let's say I need this much part. Let's say I need a length of L to bend it in the form of what? To bend it in the form of a circle of radius r. Okay. Here, what is the here? One thing, if you observe, it is a dimension that is changing. Means the length is actually getting converted to circumference. Right? When I say circumference, then the radius comes into picture. But when I talk about the quantity of the material, if I take a wire of mass m, the same mass m is applicable here.
Yes, sir.
You're able to understand. So when I write L is equal to 2 pi r, the length is directly proportional to radius. In a similar way, if I need a wire of radius n times r, then let me say I need a length of L dash. So L dash is equal to 2 pi into r dash. That is 2 pi into r dash is n times r. So can I say L dash is directly proportional to nr? But L dash is also directly proportional to mass because, why? Why is it proportional to mass? Because the wire is uniform. L dash would have actually been lambda times. So you're able to understand. So L dash is actually directly proportional to its linear density. Linear density itself is dependent on mass. So L dash is directly proportional to m and L dash is directly proportional to nr. So from that I can conclude that the mass will also get n times.
Yes, sir.
Are you able to relate it?
Yeah, yes, sir.
Yeah. So the moment of inertia of a sphere of mass m and radius r about an axis passing through its center is 2 by 5 m square. So the radius of gyration of the sphere about an axis parallel to and about and tangent to the sphere. See, this part we will do it later because I have to explain you parallel axis theorem and perpendicular axis theorem. Okay, so let's not worry about it now. Seventh one. Four particles each of mass small m are placed at the corners of a square of side length L. The radius of gyration of the system about an axis perpendicular to the square and passing through its center is. So this is also a simple question, guys. So there are four spheres. Actually, they are of equal mass only. So what is this distance? So there are actually four particles. They are not spheres also. Four particles each of mass m. So each is having mass m. Are placed at the, they told vertices only, you know, are placed at the corners of a square of side length L. The radius of gyration of the system about an axis perpendicular to the square and passing through its center. So for finding the radius of gyration, it is mk square is equal to moment of inertia. So what is the moment of inertia about point O? 4 times mass of the each, 4 times mass of each object times, what is this distance, guys?
L by root 2.
Can you write it like this? So 4m into L square. So mk square is equal to 2ml square. Both masses are same. So m and m will get cancelled. What will be the value of k? It will be root 2 times. Okay. Next. Do the next one and tell me. Make it fast. So radius of gyration of a disk of mass 50 grams and radius 2.5 centimeter about an axis passing through its center of gravity and perpendicular to the plane. So for radius of gyration, the independent quantity is mass. It doesn't depend on mass. So radius of gyration for a ring is how much? K is equal to R divided by, for a disk is how much is it?
R square by 2.
The R square. See, radius of gyration is a distance. It is R by root 2. What you told is K square. It is not K. See, whenever you read a quantity, right, you also need to check its dimensional consistency. The mistake you did is you told K is equal to R square by 2. Left side is in terms of meter, right side is in terms of meter square. Don't do that mistake. Okay. So K is equal to R by root 2. R is how much? 2.5. So 2.5 divided by root 2. Root 2 is 1.414. Just calculate it, you will get the answer. 2.5 by 1.414.
1.76.
Yes. Next. Can you try the next one? Ninth one. Moment of inertia of a ring. Again, this also is based on parallel axis theorem. So let's hold it. We cannot do. A disk of mass capital M and radius R. A disk is of mass capital M and radius R. The moment of inertia of it about an axis tangential to its. Again, this is also based on. Okay, then it's better I explain parallel axis theorem and perpendicular. So make a note of it. So parallel axis and perpendicular axis theorem. So what do they state? So write down. for a 2D or three-dimensional object, moment of inertia of the object about any axis parallel to whom? Parallel to the axis through center of mass is equal to moment of inertia of center of mass plus mass of the object into d square. So what I'm trying to say is moment of inertia about any axis P is equal to moment of inertia about the center of mass plus m into d square, where m is what? Mass of whole object, and r is what? Sorry, r d. What is d? Distance between parallel axes. So if you observe it diagrammatically, if you know the moment of inertia of any system about its center of mass, then about any axis which is parallel to the given axis, which is at a distance t, is given by this formula. Okay. I'll take a simple example. Suppose you take a sphere, okay? For a sphere, I'm talking about a solid sphere. For a solid sphere, what is the moment of inertia through its center of mass?
2/5 mr square.
2 by 5 mr square. If I ask you about an axis which is parallel to this and tangential to the surface, then what will be the moment of inertia? If I take this point P, then IP will be equal to moment of inertia of the system about center of mass plus mass of the whole object into this distance square. How much is this distance? It is r. So it is m into r square. So 2 by 5 mr square plus mr square. That will be 7 by 5 times mr square. So are you able to understand?
Yes, sir.
Yes, sir.
Similarly, you guys find the moment of inertia of a rod about any axis perpendicular to the rod at a distance of b by 4 from the center. So I want you to find the moment of inertia about point P.
Sir, the length of the whole rod is considered to be d.
The length of the rod is taken to be d.
Okay, sir.
Or is it 7 MD square by 48?
Let's check. So how did you do? It is md square by 12 about the center of mass plus m into d square by 16. Is this what you did?
Yes, sir.
So what is the LCM for both? It is 48, right? Yes, that's right. So 4 md square plus 3 md square, correct? It is 7 md square divided by 48. So I hope you guys understood. Okay. So this is about parallel axis. So when you talk about a parallel axis, it is applicable for 2-dimensional and 3-dimensional objects. Now we will think of perpendicular axis theorem. Okay. So write down the statement. Perpendicular axis theorem is applicable only for 2D. Okay. So it states like this: moment of inertia of a plane lamina. Lamina is the shape that you speak, the two-dimensional shape. About an axis perpendicular to the plane of lamina is equal to sum of moment of inertia of the lamina about two axes perpendicular to each other in its own plane. And it should, and they should, not it, and they should intersect at the point where the perpendicular axis is considered. Okay, so what I'm trying to say is, if suppose I have a disk, okay, I'm taking a regular shape so that you will understand. If I ask you the moment of inertia of the disk about a plane passing through its center and perpendicular to the plane, what will you say?
mr square by 2.
Okay. So this is, if I call this as z-axis, okay, then the moment of inertia of this about the z-axis is mr square by 2. Now, I can think of two perpendicular axes to it on the plane of the disk, right? So if I think of two perpendicular axes on the plane of the disk, such that they meet each other at the same point. They meet each other at the center. Then what are these two axes which are considered on the plane?
X and Y.
You take them as X and Y. Okay. They are nothing but the diameters of this particular disk. So then the statement goes like this: Iz is equal to Ix plus Iy. That is the statement for perpendicular axis here. See, and now I'm going to stress on the common mistake that happens. So many of them think that moment of inertia, the sum of the moment of inertia about any two perpendicular axes is equal to the moment of inertia of third. No. The moment, so left hand side, what should be there? Left hand side should be the moment of inertia of that axis, which is perpendicular to the other two axes. And the most important of all is the left hand side should be the one which is not in the plane of the lamina. But the right hand side, you're adding two values, right? Two moments of inertia. Those two values should be the moment of inertia of the system about the axis which are in the plane. If you see, diameters are in the plane, whereas the axis is perpendicular to the plane. That is why if you try to write Ix is equal to Iy plus Iz, it is wrong. Don't do that mistake. That's what the statement says. Now read it carefully. Moment of inertia of a plane lamina about an axis perpendicular to the plane of lamina is equal to sum of moment of inertia of what kind of moment of inertia of the lamina about two axes which are perpendicular to each other. And how are they supposed to be? They should be in its own plane. This is the point many people miss. So Ix and Iy are the moment of inertia of two axes which are lying in the plane of the lamina itself. Iz is the one which is perpendicular. Am I clear, guys?
Yes, sir.
Okay. And other important condition that should be satisfied is X and Y should meet at the point where the perpendicular axis is considered. That is another important point. Now, If I ask you to apply perpendicular axis theorem to a sphere and find out what is the moment of inertia about its diameter, so what will the answer be? What is the moment of inertia of a sphere about its diameters? Find it using the perpendicular axis theorem. What is the answer? Why are you thinking for so long?
Sir, is it 4 by 5 m/r square?
I have underlined some things. I know you will make this mistake. Perpendicular axis theorem is applicable for whom? Only for 2 dimension. I put a question saying that I wanted for a sphere. For a sphere, you can't apply perpendicular axis theorem. Moreover, for a sphere, the moment of inertia about any diameter is still 2 by 5 m/r square. Because sphere is going to be a 3-dimensional shape. The diameter is definitely going to pass through its center. Right, so be very careful. You cannot apply perpendicular axis theorem to a 3-dimensional object at all. You can apply it only for a 2-dimensional object. Clear, guys?
Yes, sir.
Yes, sir.
So based on this logic, you guys tell me what is the answer for the 6th one. The moment of inertia of a sphere of mass m and radius, it is given. So the moment of inertia is given as 2 by 5 m/r square about an axis passing through its center. Indirectly, it is nothing but diameter. The radius of gyration of the sphere about an axis parallel and about parallel axis to the above and tangent to the sphere. So what is the moment of inertia of a sphere about its tangent? You calculated already. I gave as an example. You people did it.
7 by 5 m/r square.
7 by 5 m/r square. So what will be the radius of gyration? Mk square should be equal to 7 by 5 m/r square. M and m will get cancelled. K will be root of 7 by 5 times r. Right? Similarly, now you guys try 9th one. Moment of inertia of a ring of mass m is equal to 3 grams and radius 1 centimeter about an axis passing through its edge and parallel to its natural axis. So it is like this. Natural axis, it is passing through the edge. So which theorem will you apply?
Parallel axis theorem.
Parallel. Just tell me the value calculation, you can do it later. If I say this point is P, IP will be equal to moment of inertia of about center of mass. So what kind of a material is this? It's a ring. So it is mr square plus
m/r square.
That's it. So 2 times mr square is the answer for this question. 10th one. A disk is of mass capital M and radius r. The moment of inertia of it about an axis tangential to its edge and in the plane of the disk and parallel to its diameter. So there is a disk of mass m and radius. The moment you need to find the moment of inertia of it. Okay. Wait, 27 is the time. Okay, we'll do one thing. We'll stop with this. Next class we will continue with all these questions. Just wait for a minute.